All right, so I'm going to start the lesson today by showing you an example of where the special angles and their precise ratios could be used. I actually don't remember if this question is going to come up in the next section of the unit or not. It might, but I know for sure you'll encounter it in grade 12. So this will be good foreshadowing for that kind of information. So find the precise answer to the following. So when I say precise, I mean no decimals, right? And you can see that I've got a variation here of all of the different special angles, 45 degrees, 30 degrees, 60 degrees, and the different ratios involved. So here's what I would do if I encountered a question like this. Now, I want to be able to do this faster than typing it in on my calculator. So the first thing I would do off to the side is I would draw out 30, 45, 60 degrees. And then I would use my trick to fill in the ratios for those. So I would go 1, 2, 3, 1, 2, 3. Now I'm at the point now, and I think some of you might be at this point as well, where I don't have to fill in the rest. I know that these are all square rooted, and then everything is divided by 2. So as long as I know which one's 30, 45, and 60, I also need to know which one's the cosine of the angle and which one's the sine of the angle. So those two columns. I'm good to go. So what is sine 45? Well, sine 45 is this value right here. So that would be root 2 over 2. Okay. What would cos 60 be? Well, cos 60 is this one right here. So that's 1/2. What's cos 30? Well, cos 30 is this one right here. So that's root 3 over 2. Whoa, that 3 looks terrible. And what is sine 60? Well, sine 60 is the one right here. So that is also root 3 over 2. And my calculator technically wouldn't help anyway, because all it would do is give me the decimal values of these. Now, usually people get pretty good at remembering that 0.707 is the sine and the cosine of 45 degrees, which is root 2 over 2. But if you forgot all of that, if you didn't know the decimal values, whatever, you could use that little trick, 1, 2, 3, 1, 2, 3, off to the side. It is, in my opinion, a beautiful thing. And then we'd have to actually do the math to simplify this. So these are multiplying, top times top, bottom times bottom. So we'd have root 2 over 4. Plus root 3 times root 3 is just 3, because it's root 9 over 2. Sorry, over 4. Almost made a mistake there. Top times top, bottom times bottom. And then we'd add the tops. Now, however you want to add the top, you can write it as root 2 plus 3. I would probably write it as 3 plus root 2 just because of aesthetics. I don't like having the radical first, but it doesn't actually matter. And then we've got our perfect answer. Precise, no decimals involved. That's where you might encounter this as an actual question. All right? So it's going to happen. I can guarantee it. I don't know if it's this year or next year, but it's going to happen. Okay, let's move on. So there's a couple of little loose ends that I want to tie up from the last lesson, mainly related to terminology. I think I may have mentioned the word terminal arm yesterday, but I can't remember. I had it in the note to do on this slide, so I just want to talk about that again. Recap that. So find the related acute angle is what the question's asking. The related acute angle is the, just a recap again of yesterday, the mirrored image angle, excuse me, the mirrored image angle in the first quadrant from the 150 degrees. And in this case, it would be, as mentioned in chat, it would be 30 degrees, right? Now, how would you calculate that 30 degrees? Well, if you go all the way to 180 and you subtract 150, you're going to get that 30 degrees, right? So what I would say is on an angle of 150, I would say the terminal arm is at an angle of 150 degrees from in standard position. Find the related acute angle. So that's the way the question might be asked. Okay, so they might mention that terminal arm in the question. Now, to make things a little bit more interesting, It doesn't have to be one of the special angles. Okay, so I could ask you to find the related acute angle to any one of these angles. Now, C is going to be a particularly interesting one. But for a lot of these, you might not even have to do a lot of math. I like to draw out where the terminal arm would be. So where is 295? Well, you need to know the base angles of 0, 90, 180, 270, and 360 to be able to figure that out. And I hope you already know those. Okay. If you don't know them, you're just going up by 90 each time. So 90 plus 90 is 180, plus 90 is 270, etc. So 295 is somewhere in this quadrant. That means I need to know the related acute angle that's mirrored from this angle here. Well, what's the quickest way of finding that angle? Mathematically, it would be 360 minus 295. Right? But a lot of you could probably do that calculation in your head. So as long as you don't get it wrong, you don't necessarily have to show me that step. It would be 65 degrees, right? So the related acute angle would be 65 degrees for that one. For 193, again, I'd want to draw an idea as to where it is. It's past 180, before 270, so it's somewhere in the third quadrant. And like I said, this one's very easy because we know that this angle is 180, so it's just 13 degrees more, right? And that 13 degrees would be the opposite angle. If you look at the opposite angle theorem, it would be the related acute angle. So this one's just 13 degrees. So that one's pretty easy to do. So if you don't want to show me any work, please get the answer right, because if you get the answer wrong, I have to give you 0. If you give me some work, at least I might be able to give you part marks. Now for C, the problem with C is, how do you figure out what quadrant you're in? Because 4,675 just means we've gone around and around and around. How many times did we go around to get to that angle? Well, how would we figure that out? Right. So chat's suggesting, let's divide by 360. Okay? Now you could keep subtracting, but it's much, much faster to divide by 360. Okay? So if you divide by 360, I actually have this calculation done from the previous lesson. You get 12.98 as your answer. And it's not a perfect 98, okay? It continues off. It's a huge decimal. And I'll come back to why I'm saying that in a second. But that means I've gone at least 12 times around the circle. So if I do 12 times 360, what it's going to do is it's going to tell me how much do I have to eliminate from the total 4,675 to counteract the fact that I went around the circle 12 times. So 12 times 360 gives 4,320. If I now take the 4,675 and subtract the 4,320, it's going to give me what the leftover is, which is 355 degrees. So that means I went 12 times around the circle plus 355 degrees, which brings me right about here. And now I can easily calculate my related acute angle, which somebody in chat has already said is simply 5 degrees. So 360 minus 355 equals 5 degrees. And that is my related acute angle. So if you have a number greater than 360, it is better to divide that angle by 360, figure out what would be the total angle when you multiply that 360 times that amount of times, and subtract that value from the total to find out what's left. Now there is another way to kind of at least tell what quadrant you'd be in. If we look at this number, that 0.98 can be considered a percentage. 98% of 360 is what it could mean. Now, since quadrants are divided in groups of 4, our first quadrant would represent 25% of the circle. Our second quadrant would represent a full 50 if you add the first and the second. Then to the 270 degree would be 75%. So 98% of the circle, I mean, clearly it would have been in the fourth quadrant anyway, but you can break up the quadrants as percentages of a circle, and whatever your decimal would be would tell you what percentage of the circle you've completed. So let's say we got like 11.2, or sorry, let me make that a little bit more complicated. So 11.37. So imagine we got 11.37. Well, 11.37 would mean 11 times around the circle, and then 37% of the circle, which is just past 25%, but less than 50, which means I would be in my second quadrant. So just looking at the decimal and thinking of that as a percentage, you can figure out at least what quadrant you're in. Now, if the decimal had been perfect, let's say it had been just 0.98, well, you could actually calculate 98% of 360 and figure out what that angle would be, and that would be another way of figuring out what quadrant and angle you have to find your related acute angle. But because the 0.98 is not a perfect 0.98 here, I can't do that. Now, that is a much more advanced way of looking at this question. Not every student is probably going to have followed exactly what I said there. But if you understand that decimals are just a percentage of your angles, it gives you another way of doing it. This is probably the best way because it works every time. But if you like the percentage way of doing it and it's a perfect percentage, that's another option. So these aren't difficult, but they do require you to understand going around the circle multiple times sometimes, like question C. Okay, let's move on. So what is a coterminal angle? So now that you know what the word terminal arm means, can you figure out what the word coterminal means? So here's an example. Find 3 coterminal angles to the one given. I'll explain what coterminal means. It says it right there. It's an angle that angles that all fall on the same terminal arm. So 100 degrees brings us to this angle. What other angles could bring us to that angle? So I've got one suggested in chat. If we continually add 360 to this, in this case we would have to use, well, not just addition, we'll talk about that in a second. If I continually add 360 from 100, that's going to bring me back to that coterminal angle, because 360 means do a full circle from that angle. So 460 would be 1. If I added 2 times 360, or factors of 360, I would get all my others, okay? So that's right, we could multiply 1 times 360, 2 times 360, 3 times 360 instead of just adding. But is adding our only option? Could I not go the other way around the circle to get to that coterminal angle? Couldn't I subtract 360? I didn't give you any domain here to be stuck between. So you could add or subtract 360 degrees and multiples of 360 degrees to get to that coterminal angle. So negative 260 is also a coterminal angle to 100. All right? So you could go clockwise or counterclockwise. Counterclockwise is positive 360s, counterclockwise is negative 360s. As long as you're doing 360 from that angle, either way will give you those coterminal angles. Now here's a question similar to what you will see on, you're going to be getting an assignment today, and you're going to actually have the day tomorrow to work on it. This is one of the questions that is on that assignment. Can you find 2 coterminal angles between negative 360 and 360 for the angle 380? And I'm sure some of you are going to find it very, very quickly. What I like to do is I like to draw a little picture of what's going on. Where would 380 be? Well, 360 brings me all the way around the circle. 380 brings me into the first quadrant. Now, it's not to scale here, okay? It is not to scale. So, but you should now be able to tell me what the related acute angle is, and the related acute angle is actually one of the angles that we need. So if we do 380 minus 360, we are going to get our first answer to this question. But I did say for two coterminal angles. So how would I find the other one? Well, I would find the other one. I can't keep going around the circle because I'm going to get bigger than 360, and I said that it has to be smaller than or equal to 360. But I can go the other way. So mathematically, how that works is if you go all the way to negative 360 and add 20, that's going to bring you to that angle. So all the way around the circle to negative 360 and then add 20. So it's interesting, the math actually follows the directions of the circles. Negative 360 plus 20 would give me negative 340. And that is my other coterminal angle that's between those two domain limits. Okay? Again, I hope it's not difficult. It might be a little bit testing on your brain because you aren't used to thinking of angles this way, maybe. But with a little bit of practice, I'm hoping that it'll become second nature and these questions won't be very difficult anymore. Before I continue, are there any questions or things that you would like me to explain a little bit more detail? I'll give you a few seconds to answer. I see one no. Okay, I'm not seeing any other questions coming up or comments coming up, so I'm going to continue. What happens if our circle doesn't have a radius of 1? So before let me read the question, but before I answer this or start answering the question, I want to show you something, okay? So it says, find the primary trig ratios for a 0.56 defined by an angle in standard position. Now, just understanding that sentence is going to demonstrate a level of understanding higher than what the average mathematics student would know, right? You have to know what primary trig ratios means. You have to know what angle in standard position now means, right? So primary trig ratios just basically means cosine, sine, and tangent, in case you're not sure. But I want to show you something. I wonder how many of you already know that this is not going to be a radius 1 circle. Let's say that this is my radius 1 circle. Okay, that's a radius 1 circle. I'm now going to draw another circle just a bit bigger than that one. If I draw a second radius for that second circle along this one, I know, it's cool. Smartboards are awesome. Somebody tell me what's special about those two triangles. That was quick. Can everybody see that those two triangles are similar? And we already know the properties of similar triangles. Similar triangles all have the same ratios. So the adjacent and hypotenuse, opposite and hypotenuse, and opposite over adjacent are the same for similar triangles if they're right angled, right? So it doesn't matter if the circle isn't a radius 1. All of the ideas are still going to work because of the idea of similar triangles. Okay? So I'm actually going to get rid of this diagram. Let's start solving this problem now. where would 5, 6 be? Well, 5, 6 is here. Okay? Now there's going to be a circle. Well, let me see if I can actually, you know what? Because I have the tools. I'll make it a little bit smaller. So 5, 6 is here now. Okay? Now what does that 5, 6 mean? Well, we saw the other day that the coordinate of this point tells you the x length and the y length of those two legs of the right angle triangle, right? Theta is here. This is your angle. I can now, as long as I have the right measurements, figure out what cos, sine, and tan are. But I'm missing one because the cosine is the adjacent over the hypotenuse, and I do not have my hypotenuse length. Well, if we call the radius c, which is my hypotenuse, I can calculate c. It's just the square root of 25 plus 36, a squared plus b squared, which is the square root of 61. So I now have my hypotenuse, which means I can list my three primary my three primary trig ratios. So cosine theta is equal to the adjacent side. The adjacent side of the angle is 5 here, over the hypotenuse, which is root 61. And I want you to clearly see that this is supposed to be the radius of the triangle, which is no longer 1. But so what? Everything still works. It's just the adjacent over the hypotenuse. Now we do have one little problem. I'm not supposed to have radicals as the denominator of fractions. So we are going to have to rationalize. So here's our lesson on rationalization coming back. So we end up with 5 root 61 over 61 as our cosine theta. For sine theta, it's the opposite over the hypotenuse. The opposite is 6. The hypotenuse is root 61. And once again, I'm going to have to rationalize that. And since it's going to basically look exactly the same as what we rationalized for the cosine, it's just going to be 6 root 61 over 61. I hope everybody can see that. And our tangent, let me just put a line here. Our tangent, theta, is equal to the opposite over the adjacent. Opposite is 6, adjacent is 5. So there's where we get our tangent. Now before I calculate the angle, which is the second part of this question, I want to discuss with you something I mentioned in the last lesson, which is that the tangent of an angle is equal to the sine of the angle divided by the cosine of the angle. Now, where does that identity come from? I'm going to show it to you now, all right? Well, it comes from the magic circle. We saw on a radius 1 circle that this length, which is the x length, and this length, which is the y length, well, the y and the x are actually just equal to the sine of the angle and the cosine of the angle. In a radius 1 circle, cosine theta is equal to adjacent x over radius 1, so it's just cosine theta equals x. Sine theta equals y. Well, tan theta would be equal to the opposite over the adjacent, which is just y over x. But we just said that y is equal to sine theta and x is equal to cos theta. So there's my proof, if you will, that tan theta is equal to sine theta over cos theta. Does that work in a circle that doesn't have a radius of 1? So just for fun, what if we use the sine theta over cos theta identity to see if we get the same answer as just looking at the opposite over adjacent? Well, what is sine theta? Sine theta is 6 root 61 over 61. And I'm going to write the division of cos theta this way. So cos theta is 5 root 61 over 61. And when you divide, you flip and multiply, right? So I'm going to flip that second fraction upside down. And now watch what happens. That cancels out with that. That cancels out with that. And what are we left with? We're left with 6 over 5. So this identity, which I'm going to put in a little box here as an aside, works even if you have a circle that isn't radius 1. Okay, we're not done yet. I said let's find the angles. So we've got cos theta is equal to, and I'm going to forget already. Cos theta was 5 root 61 over 61. Now, some of you are going to say, sir, why are you wasting your time doing all three? We should be able to find the angle with just one. Well, there's a method to my madness, and that's going to be on the next slide. So if I want to find theta, I'm just going to arc cos each one of these, right? Well, I've already pre-done this in the previous lesson, so just to save us some time without having to go to my calculator here, and you can try it where you are if you would like. The angle, sorry, not the angle, but the ratio that you would get for this fraction would be 0.6401 approximately. If we arc sine this, the ratio is going to be approximately 0.7682. And if we arc tan this, that's 1.2. All right. So what do we get when we arc cos, arc sine, and arc tan those three? Well, we get approximately 50 degrees for each one, which hopefully makes sense. You should get the same angle, right? Let's do the same thing, though, for the next slide. What happens if our point is at negative 5, 6? Now, negative 5, 6 would be over here somewhere in the second quadrant, right? So using my cosine theta is adjacent over hypotenuse. Now the adjacent this time would be negative 5 over root 61. Now I hope everybody understands that the radius is going to be the exact same as it was before, right? Because if you square 5 and square 6, the negative 5 becomes, sorry, negative 5 squared is a positive 5 squared. Same thing, right? 25. So it's going to be negative 5 over root 61, which is negative 5 root 61 over 61. The sine of my angle is going to be the exact same thing as it was before, because the height of the triangle is still 6. The radius is still root 61. So the sine ratio is going to be the exact same as it was on the previous slide. The tan ratio, however, is opposite over adjacent. Well, the opposite is 6 over negative 5, but we run into a problem here. We're not supposed to leave negatives on the bottom of the fraction. Your calculator won't know what's on the bottom. Your calculator will just know that the ratio itself is negative, so the negative is actually technically at the top of that fraction. If we arc cos negative 5 root 61 over 61, we're going to get, and let me call up the answer here so I don't have to type it into my calculator, and you can double check this in your own time. We're going to get 130 degrees approximately. But if we arc sine 6 root 61 over 61, we're going to get the exact same answer as we got before on the previous slide, which is 50 degrees, which is not the same answer as 130. If we arc tan sorry, I'm getting excited and I'm writing too fast. If we arc tan negative 6 over 5, you're going to get a third answer of negative 50 degrees. What's going on? We're using the correct ratios, and we're getting 3 different answers for our angle. Imagine for a second I had just asked you to calculate the sine theta of that point. A student gets 50 degrees and says, oh, the angle's 50 degrees. No, the angle's not 50 degrees. And the problem here is how your calculators are programmed. Your calculators don't know what quadrant they're in. You know what quadrant they're in. We know negative 5, 6 is in the second quadrant, and therefore 50 degrees cannot be the correct answer. But it's the related acute angle to the correct answer. So you need to know that because we're in the second quadrant, you have to do a little bit of math to that one. All right? So one of the things you're going to need to do is you need to identify which quadrant you're working in. To be able to correctly give me the correct answer. Now, in this case, by the way, it isn't a case where you're getting two different angles for the same arc cos, right? Because we know what quadrant we're in. The only time you're going to get two different answers if I tell you it's the answer is between 0 and 360. That's not this case. The reason we're getting three different answers is because we're doing three different ratios, cos, sine, and tan, and the calculator doesn't know what quadrant you're in. Why is the calculator giving us negative 50 when we arc tan negative 6 over 5? Because it wasn't originally negative 6 over 5. It was 6 over negative 5, which would have been the second quadrant. But now the calculator doesn't know that. The calculator just moved the negative sign to the top of the fraction. It thinks the negative 6 is negative and the 5 is positive, which means you'd be in the fourth quadrant if that was the case. So the negative 50, the answer that it's negative, is because of the way calculators are programmed to give you the angle that's closest to the positive x-axis without it being over 180 degrees. So it's a weird, I don't even understand exactly why it's done that way. But with tangent, we're getting a negative angle. We have to know that that is related to our related acute angle, right? Our related acute angle is positive 50, and you'd have to mirror image that into the correct quadrant to tell me what the true angle is. So negative 50 plus 180 is equal to 130, which is the same thing as 180 minus 50. Okay? I've done as much as I can here to kind of give you what you're going to need to start to understand this. But you're going to have to practice it to really start to grasp how this all works together. And I believe it might have already posted. You are going to be getting an assignment today, and that assignment is to be handed in. But I'm going to be giving you the entire period tomorrow to work on it, all right? So during the period tomorrow and during the day tomorrow, I'll be checking to see who's working on the assignment, but mainly during our period. And I'll be seeing if anybody needs help. And as always, you can email me for help if you want. You know, if you want to comment on the assignment or whatever you want to do to get a hold of me, and I will try to help you with that. But refer back to this note and this video that I'll be posting soon on YouTube. You can always come and watch it on Twitch again if you need to, while you're looking at those homework questions. And if you get stuck, come back and look at some of these examples. The last question is going to be probably the most challenging one. And the only hint I'm going to give you for the last question is that's one question where you're going to have to consider two possible angles. But the rest of the assignment is pretty similar to what we've just done in today's note and yesterday's note as well. So you should be able to do okay on that assignment. And I just checked and it did get posted, so it should be up on the Google class at this point. Before I leave, I'm just going to stop recording here.